What's up, guys? Coming back to you with the same lesson that we left off with, 8.5, and we're going to focus on this graphic right here that I said we would get to when we start our review, and that's going to start today. So this is just the overall view of how to factor polynomials if you're not sure which method to use, okay? So first off, I highlighted this before, you always look for a GCF anytime you're factoring a polynomial. That's the first step. Okay, so you look for a GCF. If you can factor out GCF, do that first before you do anything else. Okay, here's certain clues on what to look for and how to factor certain things. All right, now if a polynomial is factorable, which means it's not prime, you can actually factor it. You look for how many terms it has. If it has 4 terms, you're going to use grouping, and grouping was the second type of factoring that we learned after finding GCF. Okay, so just a quick recap of stuff we've already done, but just to refresh your memory. Grouping in, I got the example here, 2a to the third minus a squared b plus 10a minus 5b. Grouping means you're going to use parentheses to group terms that have common factors. So in this example right here, I can group the first 2 terms because I know they have a's in common, and I can group the second 2 terms because I know I can pull out a common factor of 5. And when we do this, we're going to do exactly what we did. We're going to pull out that GCF. So the GCF of these 2 is going to be a squared. And I'm left with 2a. And all I'm left with the second term is minus b. Now, hopefully, if I pull out that common factor with the second grouping, I get a common binomial. That's the goal when we try to group. Okay? So I know this is a little small to see. But like I said, you can probably zoom in the best you can when you guys are viewing this on whatever device you guys are doing your work on. So I'm going to pull out a 5, and when I do that, I'm left with 2a and then minus b, and that's my goal. I want 2 common binomials, which I got. So now I'm going to factor out this common binomial, 2a minus b, and I'm going to put my second binomial as the 2 coefficients of the binomial. So I'm left with a squared plus 5. All right, so that was the first method that we learned. First lesson we did on factoring after GCF. Okay, so then we did that, and now I'm going to jump over here. And so that's with 4 terms. You do grouping with 4 terms. Now let's say you only have 2 terms. If you have 2 terms, you can factor using difference of squares. Okay, difference of squares means you have 2 monomials that are perfect squares separated by a minus sign, okay? If there's a plus sign in here, that is a prime polynomial. That cannot be factored. But since this is a minus sign, we can factor this, okay? So here's an example. All right, I'm going to do the bottom one here. 18m squared n minus 2n to the third. All right, the reason I'm focusing on this is because we can do that first step, which is factor out a greatest common factor. All right, the GCF between these 2 terms is actually, well, I can pull out a 2. And I can also pull out an n, because they both have a 2 and they both have an n in common. So when I do that, I'm left with 9m squared minus n squared. This is a difference of squares, okay? You have 2 perfect squares separated by a minus sign, okay? Now, from the previous lesson, when you pull out a GCF, you leave it out there. Nothing happens to it. You leave it, okay? But I can factor this into 2 binomials, okay? If I take the square root of each one of these, then I'm left with 3m and 3m, okay? Now I get n squared. If I take the square root of that, I'm left with n and another n. Now, from the previous lesson, when you do these types of problems, okay, one of these binomials is going to have a plus sign, the other is going to have a minus sign. Because what we want is the middle term to be gone. There is no middle term here, okay? If you look at this binomial right here, it's 2 terms, okay? You got the first term and the last term. There is no middle term, okay? So when you do your FOIL, you want it so that when you multiply the outside and the inside, when you add them together, there's 0. You can even rewrite this middle term. I'm going to rewrite it down here. Rewrite this difference of squares as 9m squared minus 0mm, or plus 0mn, minus n squared. It's the same thing, okay, because there's no middle term, okay? So when you have a difference of squares, this is how you do them. You want to break them up into 2 binomials in this pattern, all right? Now, I'm not going to do the slip and slide method because that was from the previous lesson. Okay, so that's how to factor trinomials when a number other than 1 is your leading coefficient. Okay, but so this is what you look for when you're trying to factor. 4 terms, you do grouping. 2 terms, you do difference of squares pattern. And then if you get to 3 terms, you got 2 options. You got the slip and slide method, which is when you have a leading coefficient other than 1. And then you got the basic trinomial, which is in the form x squared plus bx plus c, where you're finding factors of c that add up to b, okay? And you actually use this when you're doing the slip and slide method. So I'm going to do the second example, 2w squared plus 20w plus 50, okay? So let me try and write a little bit bigger so you can see. First things first, is there a greatest common factor? Well, in this case, there is. GCF between these 3 terms is 2. So I pull out the 2 and I'm left with w squared plus 10w plus 25. Now, if you did that lesson on perfect square trinomials, you would recognize that this is a perfect square trinomial. How do I know that? Okay, when I'm factoring to 2 binomials, put it in my form, I want 2 numbers. When I multiply them, give me 25, and when I add them, give me 10. Well, 5 and 5 multiply to give me 25, and 5 and 5 add up to 10. So this is a perfect square trinomial. I can actually rewrite this. Remember, the 2 stays outside once you factor it out as w plus 5, and you're doing that squared, right? Because you got 2 binomials multiplied to each other. It's just like if you had a number multiplied by itself, you would just write that number raised to the 2nd power, okay? So this graphic right here, let me center it, is just an overall view of what to look for when you're not sure which method to use, okay? So again, the last thing I want you to take away from this is if you have 4-term polynomial, you're going to use grouping to factor. If you have a 2-term polynomial, you're going to use difference of squares pattern to factor. And if you have a 3-term polynomial or a trinomial, you got 1 of 2 options. Either the basic x squared plus bx plus c, where you pick factors of c and see if they add up to b, or you get the last lesson problems, which was when you have a leading coefficient other than 1 and use the slip and slide method.